Hello, this is Junichiro Horikawa, and today I would like to show you how to create this simple geometrical animation using a geometry nose in Blender. The version that I'm gonna use is 3.0, but should work on higher version as well. So let's do this. The basic idea to create this animation is just using a sine wave, and I'm using two different sine waves to change the size of the boxes. And that's pretty much it. So let's do this from scratch. Okay, so the first thing I would like to create is the base grid that I'm going to animate. In this case, a 3D grid with boxes placed on each grid point positions. So let's do that first. I'm gonna open up the geometry nodes layout, and let's create a new one, new geometry nodes on anything like this cube. I'm just gonna create new geometry nodes, and I'm gonna change the geometry to something so understandable box animation, something like this. And I'm gonna disconnect the input or the wires, and the first thing I'd like to do is to create the 3D grid with boxes placed on each points. So what I am going to do first of all is to create a cube, which is going to be placed on top of the grid. Okay, so I'm going to create a cube, search for the cube, and for this one I'm going to make the number of vertices for X, Y, Z to 2. Okay, now I need another cube which is going to be used as the 3D grid. So I'm gonna and for this one I need to change these vertices, the number of vertices. So let's define the numbers, and I would like to make it parametric. So I'm gonna create a one parameters using group input. I'm gonna open up the tab here on top of the group. I'm going to create a integer input. I'm gonna name this as number, and just gonna set the other default as it is, and let's go to here. Click in this box animations, click in this gear wrench icon, and you'll see this number input. So I'm gonna, let's say I would like to have like 10 grids on X, Y, and Z. Now that I have this input here from group input, I'm gonna connect this to this cube, vertices X, vertices Y, and vertices Z. And let's see how does this look like. And probably it should be better showing up the wireframe like this. Okay, so now I have a bunch of points on X, Y, and Z. Now what I want to do next is to place this cube on top of each of those points so that I can scale them to make an animation. Okay, so let's do this. In order to do that, I do need to define the size of this for each cube on top of the grid. Now to do this, you do need to calculate the single cube size by combining this size for the grid and the number of vertices. Okay, so let's do this. Right now the size is equal to 1 for the original box here. So, but there might be a chance that you want to change it as well. So let's create value here. I mean, you could also create it as a parameter here. Maybe let's do that. Wait, so I'm going to connect this empty input to this size here, which will make a vector input, which you can change both every X, Y, and Z, but I am going to change this to a float instead, so that single value applied here will go to XYZ for all the vector coordinate. Okay, so right now the size is equal to 1, and let me also change this to lowercase. Alright, now what I would like to do now is to combine these two values and create some equations to estimate the size of this cube, which is going to be on top of the grid points. Okay, so it must be small enough to place on top of each grid points. Now to do that, you could do the divisions between the size and the number. So let's try to do that. I'm going to create the math node and set it as division. So the size for this cube that I want, which is placed on top of each point, should be the size divided by the number of points on X, Y, and Z. So let's see how it goes if I place this on size for those cubes. And let's see how this cube looks like. So it looks like this and seems pretty correct. So let's try to place this cube actually on top of each of the grid points using instance on points. Okay, so this will be the instance and the grid points will be the points to play instances. And let's see the result. Now it looks pretty much like it. Now you do have a little bit of gap here. That is because actually you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and that is equal to 10. But if you want to have no gaps here, then I think you should subtract this number here by 1 in order to estimate the exact calculation of this cube size. So if you do that, have another math node, subtract this subtract this number by 1 and enter it right here. Now you can fill the gaps like this. Okay, looks good. But now that I think having a little bit of gap might make more sense or make it a bit more beautiful in terms of the final visualizations, because if you hide out these edges, it just looks like a single cube. So might be better having a little bit of gap here. So maybe I will just delete this subtract after all. So let me do that. Now if I show up the shading, yeah, you still see the edges, so I think that's much better. So I'm gonna go like this. Okay, now the base is set, so let me first create the frame, and I am going to organize, and what I'm gonna do next is to create an animation of the boxes. Now what I'm gonna animate is the scaling of each boxes, or in this case each instances, and I'm gonna use the trigonometry, in this case a sine wave, in order to change the size of boxes using this diagonal vectors as the axis. So based on this diagonal axis, I'm gonna run the sine wave and together with the frame animation time frame. So based on that, the size of these boxes will change depending on the time diagonally. So sometimes these boxes becomes larger, and when it's that the boxes on these side might become smaller and so on. I'm gonna create a wavy sized box animation. So let's see how we do that. First thing I would like to do is to create an input, the parameter, to gather the frame value. So I'm going to create another group input, and I'm going to create another a parameter, I'm gonna name it as frame. And the frame value is a integer, I think, but I'm going to keep it as a float value. And going back to the geometry nodes parameter, for the input I'm gonna type the driver name called frame, which will bring you up the current frame value, and I think it's running right now. If I go to the layout view, you see that the frame is running, and this value will be brought into this frame value and then come out from this group input as a parameter. So I'm going to use this to create the animated wave value. Now what I'm going to use it as an angle, and going to use it together with this sine wave, in this case a trigonometry. So first of all, I am going to create a math node, and I'm gonna change this to radians. Okay, so I'm gonna directly convert this frame value into a radians by assuming that the frame value is equal to the degrees. Okay, so if you want to make a loop animation, I think it makes sense to make the whole total frame numbers to 360, so that you'll have an angle between 0 to 360 degrees, which will create a one single loop as a circle. Okay, now that I have created radians as an angle and coming from the frame, I'm going to use a math node and use the sine to create a sine value, which is going to be in between -1 to 1. But what I want to do is to convert this value in for a scale value for these instances. So in order to do that, we don't really need a negative value, but we want to remap it in between 0 to 1. So I'm going to use the map range node to remap the value which is currently in between -1 to 1 to 0 to 1. Okay, now that I have this value, let's try to use this to scale these boxes and see how it looks like. Okay, now in order to do that, I'm going to use the node called scale instances. And what I would like to do is to scale these instances with this value as a scale value. Now if it's float, then all this value is going to be used for x, y, and z. Alright, now let's remove this from the frame and connect this to this geometry output and see how it looks like. And if I play the animation, seems like every box is moving in with the same speed. Every box is scaling from 0 to 1 in equal speed. So what I need to do next is to change the timing of these boxes to change its sizes. And probably what I would like to do is to based on some diagonal direction. Based on the diagonal direction, I want to shift the timing when these boxes changes its sizes. And probably I also would like to make it a little bit faster, because right now the time to change the size is a bit too slow. So let's try to change the speed first. In order to do that, I am going to create another parameter, and let's call this speed. And I think it makes sense to make it as an integer, because what we would like to do anyway is to make a loop animation, and in order to make it as a loop animation, you do need to set the frame value equal to a multiplication of 360 degrees. So if the integer value, if the speed value is equal to 1, then that's 1 multiplied by 360. And if it's 2, that is a multiplication of 2 by 360 degrees, so 720. By doing like that, you could still make it as a loop animation. So to do that, I am going to multiply the current frame value by this speed, which could create a faster moving animation. So in this case, total frame is still 360 degrees, but it's using 180 frames to have one single loop. So if you make it 5 in this case, you have 5 loops within 360 frames. Like this, it becomes faster. Okay, so I do like this speed, so let's go with this one. Now let me create a sketch what I need to create next. Okay, so let's look at the grid in 2D from the side view. So it looks like this right now. And what I wanna what I wanna do next here is to scale these boxes based on this direction. And something like this. So based on the distance, or based on this position of this direction, I would like to create a kind of a wavy pattern. Sometimes you have a small size boxes, and gradually you will have bigger boxes like that. Like that, okay? And to do this, you already have this moving or animated scale going from this to this using sine wave, something like this. So in order to create this kind of pattern, what you need to do next is to shift this sine wave based on the position of this arrow. Okay, so when consider this arrow as blue one, and when the arrow position is somewhere around here, you pick this wave. When the arrow position is right here, then you shift the sine wave to the right or to the left, something like this. Now you see that the size is changing on this intersections. And when the positions somewhere on top of this point, on this direction, then you shift this wave again, and the size becomes and the value becomes smaller as well. Continue doing this for every positions, and every time you change the position, the wave will shift, giving you a different result, and as a result, the box sizes changes based on this intersection height. Okay, so that's what I need to do, and in order to shift the sine wave, we just need to add or subtract the angle to it. So what we need to do is to create a angle value based on this directional vector. Okay, and all these boxes share the same angle, which is on the vertical direction or perpendicular direction of this base angle, or the base direction. In order to get this information, let me write up the grid as again. So this is the direction, And what we have is each point position, okay, like that. And consider the center point is somewhere around here, okay. Now getting the point position will give you this vector value, and by calculating the dot product between the unit vector of this direction and this vector for each of these vectors, in this case a position, will give you the lengths projected, lengths of these vectors projected on top of this unit vector. So let's say this is the vector, the direction that we are looking at, and this is the vector that I want to project. By calculating the dot product between this white one and the blue one, you will get the size of this projected vector from here to here. Give you this L value. And if it's on the same direction, or if it's on the direction which is less than 90 degrees, you'll get a positive L. If the direction which goes more than 90 degrees, if you have more than 90 degrees here, then you get a negative L as a value, a return value of the dot product. Now this value could actually be used as the shift angle, which I have told right here. So by multiplicate some angle value to this minus L to L, which is in between, which we don't know how much it's going to be, but by multiplying this by some angle and add it to the current current angle, which defines this sine wave, we will probably get this wavy sized pattern. Okay, so first thing first, we need to create a diagonal vector value. So let's do that by using combine xyz. And to make it as a diagonal vector, I think it is okay to say 1, 1, 1 for xyz coordinate. And let's also normalize this because we want to have the lengths of each point position projected on top of this one. So we need to have one of those vectors be normalized in order to calculate the projected lengths. So let's make a vector math, make it as normalize. Okay, and next what we want to have is the point position on each grid point. That is this one, which is the field value. Okay, now that we have two vector values, we could calculate the projected lengths on top of this diagonal vector for each point positions by calculating the dot product using vector math. Let's change this to dot product, connect two vectors together, and then by calculating dot product, now you have a value which is going to be a projected length, which also includes the negative value if it's on the other side of this direction, okay, because this is the center. But doesn't really matter because we are just going to add this value to this current angle to shift the this wave. So let's try doing this, and in order to do this, we need to kind of multiply this with some angle value in order to shift. Because if you just add these two together, this is not enough as an angle because I think it is in between somewhere around -1 to 1, which if you consider it as a degree, that's not much. Let's check. If I add it like this, you see you don't see not much changes. So in order to make this actually usable, I'm going to multiply this by some reasonable angle. So multiply, and let's see how much values that I need to multiply in order to get the wave. Now I start to see some changes. You see that the gradient scale changes start to happen here. Somewhere, if I make it too much, you see a bunch of multiple wave here, which is still okay. If I make it 360 degrees, so you have two island as a wave here, okay, which looks interesting. But what I would like to do here is to make it as 180, so that you have only mostly one island. So I'm gonna try to go with 180, but it also might make sense to make it as a parameter, but let's consider it later. I'm gonna make it as a value here so that I can test it out by changing this value later. Now I will consider this as one side of the sine wave, and what I would like to do is to create another side, and then I'm gonna combine those two together to create a animation that I'm showing in and when I started this video. Okay, so in order to have another value, I would like to shift this angle for probably a 180 degrees so that you can combine together to fill in the space that you have right now. So I think fixing this value into 180 degrees still makes sense. Let's see how we do that. So in order to shift, and in order to create another shifted sine wave angle, I do need to have another scale instances. Okay, so I'm gonna duplicate it, and I am going to do pretty much the same things right here, except using a little bit different angle. That is just by adding another 180 degrees. And then for the rest of the stuff, I'm gonna just use the same nodes like this, and connect into the same scale, and just using the same instances to scale. Alright, now that I have two instances set, I'm going to merge them together to see how it looks like. Join geometry. Alright, now starting to see something that I want. You see that the center boxes is changing, just changing its size like a wave. Okay, one thing I could do is to try to modify this scale for these two set a little bit, coming from this map range. What I want to have is a little bit of contrast between two instances. Right now the contrast is a bit too shallow, so let's try to have a contrast by adding a little math node in between this one and this one. Okay, so math node, and I'm gonna use in this case a power function, power by 2, to see how it looks different together with this one. Now you see a little bit more contrast here. If you make it 3, you should see more contrast here. Okay, so maybe parameterize this value might make more sense. So let's create group input and name this as a float power value. Connect these two. Connect. Let's for now set it to 2. Now What if I change this angle value? Does it still work? It does still work, but the shifting by these angle is overlaying some of the scales values to each other. So I think for the shifting, you still need to make it as 180 degrees. And what if I do this one? Now this one seems to work. So making the shift for other scaled instances with 180 degrees, it might make sense. And also having this value parameterized also makes sense. So let's have this as an additional parameter. How do we call this? Let's call this shift angle. And right now, set it as 180 degrees. Alright. Okay, looks good. So let's organize these by having inside a frame. Okay, select all and Control P. Okay, let me also specify the specular. Maybe raise up the specular a little bit. Change the roughness smaller so that it'll be more reflection. Box 2, do the same. Alright, now let's also change the lighting as well. Right now the light is placed somewhere around here, so let's move this closer to make it a bit more brighter. Let's also copy this. Place this on the back side. Let's have another one. Copy it. Like that. Okay, getting brighter. Maybe I could make this one a bit brighter as well. Make it 3000 watt. Let me move this to a little bit backside so that I have a back reflection. Okay, getting nicer. Now I'm also going to have some post processing effect. I'm gonna first of all make the render and viewport 128 samples. Turn on the bloom. Now it's become a bit more reflecting. Looks nice. And for shadows, I might want to make it a bit more high res. These. Turn on the high bit depths. Okay, so this looks good enough. I might raise this up a little bit. Alright, getting better, getting better. Okay, looks nice. Now I could try to tweak those parameters that I have set, like the number of grid cells. Might be okay. If I change the size, yeah, that's also fine. And frame is defined. Speed, you can make it faster. Maybe that's too fast. Make it 5. The power will create more spaces in between those two pattern. Maybe 2 to 3 might be okay for this value. Maybe 2 is fine. If I change this shift angle, you see more waves. Maybe making it 360 degrees. Oh yeah, I think I like it. So looks nice. Maybe I change this to 2.5 or 1. That's a bit too pixel like. So maybe 2 is fine. Or 2.5. Alright, think I like it. So this is pretty much it. This is how you could create this box animation, box gradient animation using geometry nodes and Blender 3.0.